Hello everyone, welcome to the class of realization of basic gates. In today's class, we are going to realize using the diodes and transistors how to realize the AND gates, OR gate and NOT gate. So let us start with the diode realization of OR gate. We know that the symbolic representation of OR gate is like this, and the truth table of OR gate is this, which says that if any one of the input is high, the output is high, and when both the inputs are 0, outputs will be 0. We are well known with this fact that the OR gate is nothing but addition of the two digits. Right? Now let us see how this truth table get verified with this diagram. This diagram consists of two p-n junction diodes connected with the help of one resistor R to the ground. Now we know that when a p-n junction diode is given a positive voltage, it conducts, it is in forward bias, and it acts as a closed circuit, therefore it is on switch, and whenever we give a 0 volts or negative voltage, the diode will be in reverse bias, the circuit will be open circuit, and nothing but it acts as an off switch. That means no current flows from one end of the terminal to the other end. So using that same concept, now we are going to apply the different inputs like 0 and 1, that is logic 0 and logic high, and see how this circuit works. So now let us start with the first. Assume that A and B are both 0, 0, 0, 0, 0. Logic low negative voltage is given to this P type. This is your diode. This vertical line represents a cathode. This is your anode, nothing but this is your P, and that is your N. And as I said, when P is connected to 0, means positive is connected to the negative or 0 voltage compared with the next terminal. So obviously this will be acting as an open circuit. It is in reverse bias, it acts as an open circuit. This also acts as a open circuit. So therefore no current flows through your device and the output will be 0. Whereas in each of these cases, let us take one input as 0, A is 0 and B is 1. A is 0 and B is 1. Then when A is 0, this is act as an open circuit. This will be act as a closed circuit. So because of that, whatever the voltage is there, that will be appearing at the output side and the output will be high. In the next case, when A is 1 and B is 0, as it is 0, this D2 will be reverse bias, open circuit. As A is 1, D1 is in forward bias, closed circuit, on. Therefore, this 1 will be coming at the output side, and therefore your output is 1. So when both the inputs are high, both the diodes will be in a forward bias and the maximum current flows through your device and the output will be 1. So this is how we can see how the OR gate functionality works with this combination of these two diodes and the resistor connected to the ground. So let us start with the next one, that is your one more basic gate, that is your AND gate. Here as this is a last minute preparation, I am not going into depth how this, by what voltage they are in forward bias or reverse bias, how much voltage drop across the diodes, and what is the output voltage appeared. It is 5 or less than 5, then how if both are high, then what happens if both are low, how much voltage difference will be. Simply a generalized overview I am just going to say, I have said here to make you simply understand what is what. When both are 0, output is 0. When both are 1 or any one of the input is high, the output will be high. That's it, without going much detail into the internal operation of these two diodes. Simply you have to remember that when diode is there, you have applied a logic 1 to it. It is a forward bias, it acts as a closed circuit, nothing but this switch on and the current flows through your device. If it is open circuit, if it is reverse bias, diode, your input is logic 0, diode is in reverse bias, open circuit, no current flows through your device. That's it. Now let us see you can see that in case of OR gate, I have kept the resistors to the ground. Now here I have connected the resistor to the 5 volts of power supply, and these diodes are connected as shown. Now let us see how this circuit gives me the functional table or the truth table of your AND gate. Now let us consider, because let us say I don't know what this gate all, as simply I know the circuit, I am going to apply. As there are two inputs, I can make a 4 possible combinations, so I am going for 0 0 0 1 1 0 and 1 1, and I am trying to see what happens at the output side. Okay, so now let us see, both the inputs are 0 0 when A is 0 and B is 0. So now you can see the cathode, the N terminal is connected to 0, and the B is also connected to 0. So as this negative is connected to negative, the diode will be in a forward bias, and it conducts forward bias. This is also forward bias. Entire thing goes to ground, and the output will be 0. In the next case, when let us say this is 0 and this is 1, when this is 0, it is forward bias, it is reverse bias, open circuit. As it is forward bias, entire thing will goes to ground, your output will be 0. Now when this is 0, this is 1 and this is 0, it is open circuit, it is closed circuit, and therefore again the output will be getting grounded. Now in the last case, so from these three things I understood that when 0 0 output 0, 0 1 output 0, 1 0 output 0. That means if I see on these three combinations, I can understand this is almost a NAND gate. So I have to verify with the last input combination, that is 1 1. Now when let us assume A and B are 1 1 1 1. When both are 1 1, that means 1 positive is connected to the negative, positive is connected to the negative. That means it is an open circuit. It is an open circuit. As if it is not there, so only this 5 volts, all these 5 volts, instead of going to the ground, it will be connecting at the output side. Therefore your output will be high. So I can see when 0 0 0 0 1 0 1 0 0 1 1 1, it gives me the functional table of your AND gate. You can see here whatever I said, this is a one tabular representation of the same. Like when both are 0, both are on, all the voltage goes to ground, output 0. Any one is 0, it is forward bias, again all the voltage will goes to ground. When both are 1, the circuit will be open circuit and nothing is getting grounded. All the 5 volts of voltage along with this voltage drop, the remaining voltage will come at the output side. So this is how the realization of the AND and OR gate which we have seen. And the last one which we have to see is your NOT, nothing but your inverter. We know that this is a symbolic representation of your NOT, and this is a truth table of it. Means whatever you give to it, it will give the complement of that. A is 0, output is 1. When A is 1, output is 0. Now let us see the same thing with the help of this figure. Now let us say your A is 0. Let us say your A is 0. And moreover, you can focus here. Earlier in two cases I had taught you the diode realization. Now here we are going to see the transistor realization. Okay. Now in this case, we know that your transistor nothing but two PN junction diode back to back. And when this is your NPN transistor, when you give NPN transistor a positive voltage, so obviously what happens? This is NPN, that means P is a base and is connected to the positive, so it is in forward bias. Base to emitter junction will be in forward bias, and the device will turn on, and accordingly the output will be produced. Now let us see. So in short, what you have to remember, like how you have remembered in a diode, whenever you give a positive voltage to the P, your device will be on, and whenever you give 0, your diode will be reverse bias, open circuit, and no output. Same way here in case of transistor, when you talk about when you give a positive voltage, it is in forward bias, same like your diode, and when there is a negative voltage, transistor is in reverse bias and no current flows through your circuit. Now when you have given 0 here, means obviously this P is connected to 0, nothing but reverse bias. no current flows through your circuit. That means this transistor will be this transistor will be open circuit, and therefore whatever the VCC is there, that will be appearing at the output side. That means when you give 0, you got 1. When you give 0, you got 1. In the second case, when you give A equals to 1, that means 1 is given to the P. That means base and emitter of the transistor is in forward bias. Transistor will be on, and all the voltage, as it is a short circuit, current fall always try to go to the shortest path. It will directly go to the ground and the output will be 0. That means when you give 1, you got 0. So we can see we are getting the output which is a complement of your input. So I can say this circuit gives me a inverter realization, or inverted output I am getting at the end. So this is very short and brief about the basic gate realization using diodes and transistors. In the next class, we'll talk about RTL, DTL, DCTL and TTL. Till then, thank you.